So we're going to look at compound interest. So we've got a question here. Gwen wants to invest 20,000. She must decide between a 12-year plan with an interest rate of 8% per annum. So that's once every year. That's what per annum means. Compounded quarterly. And a 12-year plan with an interest rate of 7.75% per annum compounded monthly. So which plan will earn Gwen more interest and by how much? So the first thing we want to do is essentially get our compound interest formulas. And the best way maybe to set this up, depending how they've taught you, is the future value of some interest is equal to the present value. And sometimes they just leave this letter as P, like the principal or something like that. But it also stands for the present value. So I'm just going to leave it like that. Times 1 plus I. And I, there's actually a calculation for, to the power of n. Okay, so FV is your future value, just fit that in. PV is present or principal value, same word. I is actually equal to the letters R over C, and R is your interest rate. I like that I can handwrite, so it makes no sense because you can't read it. And C is the compound period. Compound period. And then finally, n is also a formula. So I'm going to point that out too. It's your compound period times the number of years. So C we've already defined. YR is years. So there is a ton of variables involved here. We just have to know what each of them stand for. Really, I could have broken this I into R over C and this N into C times YR. Okay, those are both actually the equivalents of these, but they tend to just represent them with those two variables instead. Okay, so now that we have that, we can go about trying to calculate at least our first one. So I'll read this again. Gwen wants to invest 20,000. So 20,000 is the present value. Okay, so our present value in this is the $20,000, and that's this. And again, sometimes they call that the principal. So in order to do our calculation, we're going to have to put in our $20,000. Okay, I'll leave the rest of this stuff the same for now. And we'll keep piecing things together to figure out what variable we're trying to find. The next thing they told us is she's going to have a 12-year plan. Well, that is going to be the number of years, so your YR. So we can highlight that. Years is going to be equal to 12. But YR doesn't give us enough. We're also going to need to know the compound period along with that. So keep reading here. With an interest rate, okay, we're actually looking for compound period next, but I can also write this in. Interest rate, highlight that in blue, there's 8% per year. Interest rate is actually the R value, which is again a piece of this formula. Just like years is a piece of that N formula, R is a piece of that I formula. And compounded quarterly, that's what's really important. I hope this isn't too dark. Oh no, that worked. Quarterly. So compounded quarterly means happening 4 times a year. Okay, so that's our compound period. That's part of both of those formulas. Okay, so now that we have R and C, we can calculate I. Now that we have C and YR, we can calculate N. So I'm going to put those values in and show you how we can calculate them. So the one thing we're trying to find, it looks like, is future value, because we don't have any numbers for that. And that makes sense, because they're asking, and really they're comparing 2 types of formulas here, or 2 types of accounts, that's the word. Which plan will earn more interest? Well, we got to find the future value to figure that out. So I have 20,000 as my present value. 1 is still the number 1. I is R over C. Our R value is 8%, but we turn that into a decimal, so it should be 0.08. Okay, divided by our compound period, which was quarterly. Quarterly means 4 times a year, so we're going to divide by the value of 4. And this is all to the power of n. N is your compound period, which is 4 again, times the number of years. And the number of years we said was, where is it? Here it is, 12. Okay, so we've now gone about filling in PV, I, which is those 2 variables, and N, which is these 2 variables. The only variable left is our future value. So we run this through the calculator, and it'll tell us what the future value of our investment would be. We'll quickly calculate it here. FV is equal to 20,000. I got a calculator here somewhere. There we go. 0.8 divide 4, I think should be 0.02. Is it? Yeah? Okay. And plus 1, so that's going to be 0.02. And 4 times 12 is 48, so to the power of 48. So what we really need the calculator for is putting together 1.02 to the power of 48 times 20,000. And it should follow BEDMAS, but I'm going to put brackets around just to make sure. According to this, we should have $51,741.41-ish. Is that what you got?
Yeah.
Yeah? Okay, so 51741. 51741. And I said about 41 cents approximately. Technically 40. So that's the future value of the first account we're in. Side note, they're going to ask how much, who earns more interest and how much. That's just a simple subtraction by the two. But to calculate interest, we take the original amount and just subtract what our final value is. So we would take this $51,000 odd and we subtract the $20,000, and it's going to be $31,741.41. That's a great interest rate, okay, that we've got here over 12 years. Yeah, it's a really good interest rate. Oh, it's because it's earning 8%. That's absurd. Nobody gives you that much money in life. But that's just the point to know. So the second part of this formula is the second account. Exact same formula, exact same process to set up. Instead of going through the variables, I'm going to try to set it up just from reading it. So it's a 12-year plan, so that means that's the years. It's a 7.75% per annum. Compounded monthly. So monthly, our C value is actually 12 in this case rather than 4. And the present value is still that 20,000, and he doesn't have a different amount to invest. So still looking for future value. Oh, it's Gwen, right? It's a guy, girl? I have no idea, actually. 20,000. The interest rate is 1 plus, and it was 7.75, so that's 0.0775. I'm going to check that again. Yes, that's right. Divided by the compound period. The compound period, I should have put this in green, just so you can make a relationship between those interest rates. The compound period was the value of 12, so that's how we calculate that I variable. And our N variable is 12 times, and in this case, it's 12 years. So it's 12 times 12. This value I'm going to need a little help with a calculator to calculate. 1 something. It's going to be the power of 144. That's what 12 times 12 is. 0.0775 divide 12 gives us, okay, so a pretty long decimal value. It's approximately 0.0645 and 3 repeat it, so 0.064583 repeated. Is that what it said? Did I really just get that? I doubt it. 6458. Oh yeah, I did. Oh no, there's 2 zeros. There you go. Now I'm going to keep that number in the calculator because any rounding is technically going to reduce or actually increase the amount of money we're supposed to get. So we're going to try to be as specific as possible. So this is so that we can visually see what that decimal is. But when I go back to the calculator, I'm going to use that long decimal to actually go about solving this. So I'm going to need to add 1 to it because I just did that in my head. But I need to add 1 because there's 1 plus that interest rate. So I'm going to take that answer, plus 1. So here's our new value. It's to the power of 144. There's another new value. And then that's going to be times by, or multiplied by, not times by, 20,000. So $50,583. I didn't get the cents. $583 and 83 cents. Oh, 38. Yeah. 83 cents though, was it?
Yeah.
Oh, maybe that's what I said. So, $38. Okay. So we have our 2 future values here. Obviously, the 51,000 is more. They want to know, what was the last part of this question? Which plan earns Gwen more interest? So plan 1 is clearly the plan that's better between these two. And by how much? That's just a simple subtraction of these 2 values. I'll quickly do it. So by how much? We'll take green for money. 51,741.41 subtract 50,538.83. Let's get a calculator here. I think those answers should actually be saved in it. think it is. Can I work with my calculator? Kind of. There's that answer. Subtract this answer. Oh, that's so convenient when the calculator has memory. $1,202.57. 1,000. I got the 57 cents, but I already forgot the dollar amount. $1,202. I think that was it. Yay. Okay. So, just to kind of recap. Future value, we calculated for two different formulas here. They both had different interest rates and compounding periods, and that's what made the difference here. The difference in interest is obviously just subtraction of the two. If you ever want to figure out how much interest is earned, you just take the original amount, subtract by the new amount. Another variable they sometimes ask you to solve for is the principal or present value, which means they would give you the future value. A lot of times they give you a whole other formula for that. You don't need another formula. You can just set the formula up. Let's say the future value was 20,000. We would have put 20,000 in for FV, and PV would have been our unknown, and we would have just manipulated the equation to get some value here and bring it to the other side to solve for PV. Instead of having to memorize two formulas for compound interest, you can just have this one formula, and it'll work for both present and future value, and whenever you need to solve for interest rates or compound periods or years. Okay, just a side note there.